Today's lesson is on graphing what's called piecewise functions. The objectives today is to define a piecewise function and to graph piecewise functions. Some of the vocabulary we're going to come across is piecewise functions, inequalities, domain, and what's called a subdomain and subfunction of a piecewise function. The definition of what a piecewise function is. Basically what a piecewise function is a function which is defined by multiple what's called subfunctions. These subfunctions pertain to a particular domain. These are called subdomains. So this is an example of what a piecewise function looks like. Notice here we have three different functions going on. We have f of x equals -4, f of x equals 2, and f of x equals x minus 1. And they all pertain to different subdomains, such as x less than or equal to -1, anything between -1 and 3, and anything greater than 3, we use this function. So the graph of this piecewise function would look something like this. Notice how we have open and closed circles in this graph. They pertain to the less than or equal to symbols and less than symbols that you see here. Notice how our first subfunction is f of x equals -4. It's a horizontal line right at y equals -4, and we use a closed circle because of the less than or equal to symbol. And then anything between -1 and 3, notice how both the less than symbols are here, we have open circles, so it looks like a line segment right at y equals 2, because that's our subfunction. And then anything greater than 3, such as 4, 5, 6, and so forth, we're going to use the function x minus 1. That's why you see this diagonal line right here, continuing on from x greater than 3. So this is an example of a piecewise function, the function notation of it and the graph of it, what it looks like. So let's try a few. Here's an example of a piecewise function. We're going to use f of x equals -4 for anything less than 0, and we're going to use f of x equals 3 for anything greater than or equal to 0. Let's first start off with our subdomain of less than 0. Notice how our function is f of x equals -4. Just like the last example, f of x equals -4 is going to be y equals -4 as a graph. It looks like a horizontal line right at y equals -4. But since our domain is anything less than 0, we're going to stop the graph right at x equals 0. Are we going to use an open or closed circle here? You guessed it. Because of the less than symbol here, we're going to use an open circle. So it stops right here. Now let's take a look at the next subdomain. Anything greater than or equal to 0, we're going to use the function f of x equals 3. Very similar to the last example, f of x equals 3 is going to be y equals 3, so it's a horizontal line right at y equals 3. Are we going to use an open or closed circle here? Notice how our symbol is greater than or equal to, so we're going to use an actual closed circle right at x equals 0. So the line looks like this. So this is what the piecewise function looks like for the function above. Let's take a look at a little harder one with 3 subfunctions. Let's start off with our first subdomain, anything less than -2. We're going to use the function f of x equals -2. So again, it's going to be a horizontal line right at y equals -2. But in this case, we're going to use an open circle stopping at the value of x equals -2, because that's our subdomain. Anything less than -2 is this function. So it's going to look like this. The next subdomain is anything between -2 and 2, we're going to use the function f of x equals 1. Notice how in both symbols here we have less than or equal to and less than or equal to here. So what kind of circles are we going to use? Closed circles. And this function is y equals 1, so it looks like, again, a horizontal line right at y equals 1. But in this case, we're going to use the closed circles, so it's going to look kind of like a line segment between -2 and 2. Our last subdomain is x greater than 2. So any value greater than 2, such as 3, 4, 5, 6, and so forth, we're going to use the function f of x equals 4. Again, it's a horizontal line right at y equals 4. But in this case, since our domain is strictly greater than 2, we're going to use an open circle starting at x equals 2. So the function exists everything greater than 2, and it looks like this. So this is the graph of the piecewise function above. Let's take a look at our last and final example, then you can try some on your own. f of x equals -x for anything less than 0, and f of x equals x squared for anything greater than or equal to 0. So let's take a look at our first subfunction. Now what does this mean? This means that any value less than 0, such as -1, -2, -10, and so forth, we're going to use the function -x. But any value greater than or equal to 0, such as 1, 10, 20, and so forth, we're going to use x squared. And you should be familiar with some of these functions and what they look like. Let's take a look at our first function, which is f of x equals -x. Now what does this look like? In chapter 2, you remember graphing these lines. In fact, this is going to be a diagonal line with a slope of -1, and it actually goes through the origin. So what it looks like is this. But since we're going to only worry about values less than 0, again less than using an open circle, it's going to stop it right at the origin. So it's going to look like this. Let's take a look at our next subfunction, which is x squared. What does f of x equals x squared look like? Well, hopefully you should be able to tell me the shape of this. We just finished our quadratics unit a little bit ago. So the function looks like a parabola. So it looks like this. But in this case, we're only worried about anything greater than or equal to 0 for this function. So greater than or equal to meaning we're going to use a solid circle, and anything greater than, we're going to use that part of the parabola. So the final function looks like this. So tomorrow we're going to practice some of these, graphing these piecewise functions. I would like you to attempt the questions below on the Google form. Try your best and get ready to practice tomorrow. Enjoy.